let's see how we can find continuity interval of a piecewise defined function. So we have a function that is linear when x is between -1 and 1, and is a parabola when x is between 1 and 3. So let's draw some schematics. So not full-blown picture, but some schematics. Okay, so I have -1 and 1, and the borders belong. So right here, that would be my purple kingdom, -1 and 1, and the law of land here is y is equal to -5x plus 6. Now, my other kingdom is 1, where the border does not belong to it, and 3, where the border does belong. So I kind of maybe will draw another border that does not belong, and then 3 here, and that's my red kingdom. And the law of land here is y is equal to x squared. Okay, so to the left of 1, I have a linear function which is also could be considered polynomial function, and it's continuous everywhere. To the left of to the right of 1, I have a polynomial function that is also continuous. Okay, so my only suspicious point is at the border, because this function can stop and then another function can begin with a gap. So then I will have discontinuity on the border. But inside this interval and inside that interval, I absolutely cannot have discontinuity, because I know inside information on these functions and they're very nicely behaved. Okay, so let me say I need to investigate only continuity at point x is equal to 1. So how I do it? First, I find the left limit. X approaches to 1 with deficiency f of x. Okay, now to the left of 1, my formula for f of x is this. So this is what I am gonna harvest and substitute here. X goes to 1 with deficiency -5x plus 6. And now I can substitute directly x is equal to 1. So I will get -5 times 1 plus 6 is equal to -5 plus 6 is 1. Okay, that's my left limit at 1. My right-handed limit at 1. X goes to 1, but with excess f of x. So now my function is different. I have to harvest this formula for f of x, because on the right my function is x squared. Okay, now that I know what formula to use, I plug in direct substitution. X is equal to 1 into x squared, so I get 1 squared. What do you know? It's 1 again. Wow! So the left-handed limit, which is also equal to the value of function in the point, because 1 does belong here, is equal to the right-handed limit. So my function is continuous at 1. Continuous at x is equal to 1 as well. So my continuity interval is going to be where the function is defined from -1 to 3, right? The function is not even defined beyond this interval, so I don't know what happens to the left of it and to the right of it, right? But this would be, yeah, continuity interval.